Hello and welcome to this joint webinar with ANSYS. My name is Oliver Kühlert. I am the Technical Product Marketing Manager at Cisco. I'm here today with Chafik Jabbar. He is the Lead Application Engineer at ANSYS, and together we will talk about the Railway Software Design Challenges, the ANSYS and Cisco design workflow. We will go through the safety software design and validation, the integration of the safety software within the operating systems, and finally conclude with a demo on a system running on the hardware in the loop with a physical board. And now I hand over to Chafik to start the presentation.
So one of the challenges we wanted to tackle with the collaboration with Cisco is the how to manage the autonomy in an efficient way. And when asking about this and when trying to research about this topic, we found out that to really describe an autonomous system, we need first to have a language that supports the autonomous description of the embedded software, and to have the appropriate means of expressing the needs, and then creating the code out of it, and then porting it into a safe environment. But what we have seen as well, railways systems, when you are designing the software, you are always looking to reduce the software verification costs. Software design is very important, but then the verification and validation of the software usually take a big part of the cost of a project. And every percent and every reduction in this time can help you to reduce the cost, and especially the time of your project. Another challenge that we have seen that is faced in railway industries is to manage the interoperability. You have an existing legacy, you want to port it to a new device, you want to be sure that you will be able to take this legacy with you. You don't want to be stuck in one closed environment. And for sure, we should not forget about the optimization of the overall system performance of the software and of the integration with the hardware. Railway systems are software-intensive system reacting to several stimuli, and you need to have an overall performance that is respecting the constraint of the standard and of the operating environment. And at the end, you should as well ensure that you have a functional safety and security respected. You need to have your software running in a safe environment and in a secure environment. You want your operating system really to ensure the security of your system, and all of that is interconnected together. That's why we teamed up with Cisco to address these challenges and to offer you an integrated solution that is qualifiable to design the safety critical software using a model-based development suite approach that is escaped from ANSYS, and an operating system for high integrity embedded software that is a PikeOS coming from Cisco. The benefits you are expecting from this, that we guarantee for you the software safety from design to deployment using certified code generation and certified operating system. This integration between the software design and the OS integration is a seamless one. ANSYS and Cisco created all of what is required to make it a seamless integration. And again, one advantage you are expecting here is reducing the validation and verification cost and time, and to achieve high performance for your safety project, especially that we are supporting multi-core as well. And these solutions are developed in fully compliance with safety standards that comes in the railway domain, such EN 50128 and the EN 50657. These solutions are as well certified and compliant with other domains and other standards if you are interested. What we will go through today is a bit of this V-cycle, a detailed step-by-step of the integration. We have on the left of this V-cycle our system and architecture and software architecture design with ANSYS SCADE Architect. Once you have defined this architecture, you want to move the software design with ANSYS SCADE Suite and SCADE Display. But before going to the target, you want to do the full verification and validation on the functionality very early on in your design, and even before the availability of your operating system and of your target. That's why you have this small v here going with the model test and coverage with ANSYS skate test. And eventually, if you have some system simulation tools, in our demo here, we use the train simulator game from DovTrail, but it's a game in this context. But if you have a system simulation environment of your own, we have means to integrate it with ANSYS Skate Suite to have your software running with your system simulation. Once you have done this functional verification, you will move on to do your software integration to the other part of the right of the V-cycle. And here, the platform Codio from Cisco will help you to perform the integration of the Skate Suite and Skate Display models into an your embedded tasks and compile it with a specific dedicated compiler. You can run this as an emulation on your PC using the QEMU that is supported directly by the Codio environment, or you can at the end take it to the target. And in our example, we have a board from Xilinx, and we have ported all of the software plus the operating system to that Xilinx platform, and we connected it to the system simulation environment. So let's start with the very high level of the architecture with Skate Architect. That is a tool developed by ANSYS to help you to take from on the top right of this slide your customer requirements, your customer needs, to do some functional analysis and understand what are the functionalities that you have, to later on write on the second part of the right side your system requirements, which are your company language and keywords to describe the customer requirements. And in this stage, you will be able to design the architecture, the functional architecture, software architecture, and hardware architectures. Just what are the subsystems and what are their interfaces. Once this stage is complete, you can move on to create software requirements, and ANSYS Skate help you to generate a Skate Suite, our tool for control software environment projects out of your system architecture, closing the gap between system architects and software engineers. Once you have this top level of the software architecture, you can move on to the software design using ANSYS Skate Suite and Skate Display. Skate Suite is our tool to design control software, and it's there to handle mainly two main key challenges. You need to design complex embedded systems to do control, monitoring, protection of your railway systems, and to handle new topics such as autonomy and others. And in the same time, you want your code to be safe and to be compliant with safety standard, which is a bit difficult if you are using some existing approach or manual code and so on. So what we brought is a Skate Suite for you that is a language to help you to formally design your systems, your software. It's a model-based defined language designed since the beginning for control system with safety in mind. Skate Suite comes with a code generator that is certified to generate C code and ADA code for the EN50-128 standard. What does it mean having a certified code generator? Is that the generated code is equivalent to the model. So you don't need to have additional activities on your code, on your generated code. No code reviews, no other verification and traceability on the code level. Everything you will put is in your model. The result as well from this model approach is to generate the documentation of your system, of your models, directly from the Skate Suite that comes with a report generator that is qualified for your system as well. So you will take this report and send it to your certification authority, and you will be sure that they will have access to every element of your model in a report form, and you don't need to do any additional activities for that. The benefits of Skate Suite is you will be saving some engineering time because you'll have more and more models, and you will be able to reuse them, and Skate Suite has the capacity to help you to reuse the existing models. But as well, you will have big portion of the document required by the standard be generated from the models. And you will reduce the complexity in design because we are offering you a design language that is a high level, a model-based language, not as detailed as it could be in C or manual approaches. And this will help you to achieve faster time to market, but it will help you as well, all of that, to reduce the time for testing because the code generator is certified and you don't need to do testing and validation on the code. Skate Suite is good for controlled software design. Now we have Skate Display that will help you to do embedded HMI design or DMI in the railway domain. This is an example of the DMI we have designed for the demo today. Skate Display offer you what you see is what you get editor. What you are seeing on your screen now, you will see it on your target platform. Skate Display does not require any, let's say, software engineering capacity. So anyone, especially system engineers, can directly write the specification of the DMI in Skate Display. It offers you primitives and libraries to quickly in starting your design. And finally, it has as well a certified code generator where you, in a push button approach, you will be able to generate your C code out of your graphical interface. The Skate Suite and Skate Display code generators are certified in Railway up to SIL 3 and 4. We offers you all of the required documentation and artifacts to prove this certification via certification authorities. In aerospace as well, it is certified. What is fascinating about this is it is certified in 6 market segments by 10 certification authorities worldwide. And we are used to have these certification authorities auditing the SCADA process and validating what we are performing on this one. So once you have this code generator, your activity is to now try to test it and validate it as quickly as possible. Because finding errors late in the design cycle can cost you really high. And the test phase should, what we have found is sometimes it starts really late because we say, okay, I need to develop the software, kind of simulate it, debug it a little bit, see what will happen, see until I have the target and so on, and then perform the formal testing and validation until waiting for the target platform to be available. Skate Test, on the other side, is really an environment based on your requirements, always on the software requirements that you have. You will be able to test the Skate Suite and Skate Display, the control software and the graphical software based on the requirement and to verify that they are implementing correctly the requirement. In Skate Test, you will be performing functional testing on host on your PC on the models very early in the design cycle, and you will not be waiting for the target to be ready. You will not be testing the software, the generated code itself. You will be testing the models, and ANSYS guarantee that the tests you have achieved on the model are equivalent to what you will have on your code. At the end, Skate Test as well generate for you a report, a compliant test report that will list the test that you have performed and what has been successful and what has failed. And that report is as well qualified that you can share with your authorities. Using Skate Test, you will be able to detect the errors early in the design cycle, and you will be removing the model to code back-to-back testing phase or unit code testing because the code generation is certified process. Once testing is complete, you can check if your model is, thoroughly tested. That's the model coverage part. Some challenges that we have seen is sometimes you want to see what is the contribution of each test case, let's say in a covering of the model. Or if you are using some other model-based approach than Skate Suite and Skate Display, you want to be sure that you would need to do model coverage plus code coverage and so on. In ANSYS Skate model coverage, you will use the test case that you have developed in the for the testing earlier to perform the model coverage. In the case that you have if you have executed your software, let's say on some target, on some simulation environment, and you have existing scenarios, you can as well use them to add to the coverage. At the end, you run these different scenarios. Skate model coverage will will merge the results and provide to you a synthesis, a report that is guaranteeing that you have covered your model for both model and and code coverage. The advantages of model benefits of model coverage: you will detect if you have any shortcoming in the requirements-based test procedure, if you have tested all of the requirements, if you have you don't have any dead software parts or deactivated software parts. And again, with ANSYS SCADE model coverage, you are sure that you will achieve model coverage and code coverage with one single activity. 100% of code model coverage implies 100% of code coverage. And we provide you the artifacts to share with your certification authorities to really validate this claim. One other aspect that is popular in railways, and it has proven its merits, is to do formal verification and formal proof on your models to be sure that some events will never happen or some events will always happen in an exact matter. ANSYS SCADE comes with a design verifier where you will use SCADE suite language to specify the properties, the formal properties. We have already some existing one defined, such as the division by zero, the overflow, and so on. You run the formal proof on that. The design verifier will prove, for example, that the property is always satisfied. On the other case, if it finds it's falsifiable, it will generate for you a report and a scenario, SCADE test scenario, and containing a sequence of events to tell you where is a falsifiability of the property and how you can come back with that. So this will help you to represent the formal verification of the software safety properties. SCADE has been used in railway in several systems, such as onboard control protection for ETCS in Europe, CBTC in general, emergency braking, and so on. For interlockings, for train detections, for the even on board for the platform and cabin, for the mechatronics control systems, and SCADE display has been used for the for DMIs on several railway system. If you have some curiosity and you want to see some, let's say, open source SCADE model, there is a European project that is called the Open ETCS, funded by European Union, and with the objective to provide a tool chain to develop ETCS software. The onboard ETCS software is designed with SCADE Suite. The DMI is designed with SCADE Display, and you can access this model from their website that is visible here. So now we have performed testing and coverage, and now let's ask if I want to run my train, I make my train circulate for 200 hours on 1 million kilometers and get all of the results and all of the scenario and simulate that with SCADE Suite. That's what we will achieve with the with a system simulation like this train simulator here. We have connected SCADE Suite and the train simulator to do this closed loop simulation, where in the train simulator you will have some a driving environment. You can create your scenarios and you can have some train dynamics, limited ones, but you can still use it. And then on the other side, on SCADE Suite, we have created the autonomous train embedded control software. Here it's a basic example controlling the speed and the acceleration and the braking. And we have connected these two tools together. The benefits is you will be able to analyze your software in a white box co-simulation, directly see the impact of your software on the train. You will be able to generate rich driving scenarios that you can save on your machine and then close the simulator and just open SCADE and launch the simulation inside SCADE and be able to simulate these new scenarios in your environment and go step by step analyzing them. And this will help you to achieve the validation of your safety software design into a realistic virtual environment. Now our software is functionally tested, is verified. Let's go to the integration on the operating system and on the platform. And at this stage, we will use the Codeo environment from our partners from Cisco. In fact, the global process of integration will be the following. You have your, let's say, software requirements in any of the requirements traceability tools you are using, DOORS, Polarion, JAMA, PTC Integrity, and others. You have that connected to SCADE Suite and SCADE Display to generate to create the models of your software and DMIs. This will help you to run the simulation and testing with skate test, as you have seen before, for both environment, and then you can generate the code out of skate suite and skate display code generator that is qualified for AN 5128. At this stage, your question would be, okay, I have a C code that is standard that can run on top of any platform. Now I want to integrate it into PikeOS, and we have created the wrappers to generate a specific integration to port the code generated from Skate into PikeOS environment. And at this stage, I will pass the hand to Oliver.
So as told before, we have a setup here on a Xilinx UltraScale board with two Picos instances, one running on the A53 core and one on the R5 core. We will come to this architecture later, and I just want to give you a few information on the Picos operating system itself. So the basis of Picos had been L4, which is quite a few years ago. And L4 was one of the first microkernel which had absolutely no performance issues anymore. So at the early beginning of the microkernels, the Mach kernel was actually doing its task, but it had a severe performance overhead. And with DL4, the first microkernel that was really as performing as a naked system was introduced by Jochen Liedtke. On top of this, Cisco chose to build their own operating system called Picos. And in addition to the original kernel, Picos has been designed for safety, security, and it made another performance leaps by adding a few other things which made it a little bit more handy in industries. Picos had been designed for safety. In fact, we came from the avionics sector where Cisco had made a few certifications up to the highest standards for different aeroplanes and different other companies, and then started their own operating system, which was first used in the IA400M. Picos is compatible to the highest certification standards, but in addition has made a lot of improvement, especially when it comes to real-time and time partitioning. So this is the basic architecture. Below we have the hardware, and then we have the microkernel itself. The microkernel is modular, which means it consists of the bare kernel itself, an architecture support package, which supports the major architectures like x86, ARM, PowerPC, and very soon RISC. And in addition to that, we have a so-called platform support package, which implements the layer which is important for the board startup, serial mode, and so on. Once the Picos kernel has been started, it starts the first user software, which is the Picos system software, which implements the strict partitioning by means of the support of the kernel. So in this example, we have 3 virtual machines which are being executed totally, completely independent from each other. So this is a list of the Picos guest operating systems. Picos itself can run para-virtualized operating systems. If you choose to do so, you have to modify your guest operating system, but you win a lot of performance. In addition to that, Picos can also run fully hardware virtualized. In this case, we can execute unmodified operating system such as Android, or even, well, we did this as a proof of concept. It's not an official project, but possible anyway, even Windows. In addition to that, we have our ARINC partition, which was very interesting in the very start. And we can also run Linux, ADA, etc. in parallel. In case of the ANSYS Skate suite, which in fact is the model which is running on top of the Picos native API, which uses the Picos operating system. The Picos native API has already been certified to the highest certification levels. That means in combination with the SCADE suite, we have a fully certified system available for high critical system. When it comes to development, we have our integrated IDE. This IDE is based on Eclipse and allows to integrate other third-party plugins as well. This system has a full-blown C++ editor with all the, let's say, convenience functions you have, like code snippets, syntax highlighting, etc. Today, this is not really important because we are not going to write any code. Everything here will be automatically generated by the ANSYS suite, which is always nice to see that you had a model running before in the SCADE suite directly on your host system, and then it runs directly on the target without any modifications. What Codio also has is to simulate your target hardware. If you don't have it at hand, for example, if you're working in a big team, then you can simulate your target hardware on the development host PC by means of Codio. The whole tools you need to transfer your application to the target, for example, TFTP, is fully integrated. In fact, you will see later a video where we transfer the image via TFTP so that you can turn to the target seamlessly. When using TFTP, this takes a little bit more time than actually on the real hardware. So the production image will be based in Flash, and then Picos comes up in a glimpse of time. In addition to that, we have a target system monitor, target system tracing, which is kind of an oscilloscope, which shows you what is happening on the target in a way that you can actually optimize the system, find bugs, and see the interactions of the virtual machines. In addition to that, we also have fully remote debugging, and the development IDE is available for Linux and Windows hosts and tightly integrated with the SCADE suite. Picos has been certified to the highest level. We came from the avionics, and there we can be certified to Del E. In industrial automation and railway, we are ready for SIL4. In fact, Picos was the first operating system on multi-core that had been certified according to SIL4 for the railway sector. In automotive, we are ready for ASIL D. Almost all of engineers have experience in certification projects, and if you're planning to do a big project, we can assist you at every step of the development of your project. That's, for example, with ANSYS in the early stages, the whole development. When it comes later to testing and code coverage, we support all major debugging probes and usually can help you getting 100% code test coverage. And then we have a few reference certification customers in the avionics and railway world. So these are the certified Picos components. Of course, we haven't pre-certified your code because this is still in the making, but we can assist you. But on the side of the guest operating systems and certifiable APIs, we already have certified our Picos native API, and we have a POSIX API, which is also ready for certification. What we fully have certified is our Picos system software, the microkernel, and the architecture support. The platform support packages, of course, need to be certified because that depends on which board you're going to use. Of course, we already have some boards, but just ask sales for the already certified boards. So in similar to what ANSYS does with their tools, we have fully qualified our toolchain. And this is especially true for all our building tools which are in the build chain. So when you configure PyCos, we are talking about configuring a virtual machine, and this requires basically two big components. One is the definition of the rights of the virtual machine, and the other one is about what is in the bootable ROM image. Usually, the tools are not validated, which means that you have to do the validation on the binary side, which is very tedious and totally needs to be redone when you make little changes. But since our toolchain is completely validated, you can do the validation on the source code side. And if you have changes, you can track those changes incrementally. We have certification kits for all of our major industries. These certification kits contain all the artifacts, starting with the overview documents, PSEC, requirements, high-level requirements, documents, design, architecture, and so on, down to the test cases. All of these documents contain unique IDs so that you can simply embed these documentation into your certification project and have a complete traceability from the top level down to the source code. These are our security certification kits, and we also have a certifiable IP stack, which is UDP only, but it's extremely small. And we have a certifiable file system, which can be linked against our POSIX personality or our PyCos native personality. One of the most important features of PyCos is mixed criticality, which means you can have your critical application certified to the highest level. And typically, these have a very low number of codes. If you need features or legacy code that does not fall under, let's say, safety or certification issues, Cisco can guarantee you that you can certify the critical application to its own highest SIL or DEL level on its own. And we guarantee you isolation in terms of memory, I/O resources, and time. How do we do this? Well, actually, there are two basic mechanisms. The first one is resource partitioning. Here we have an example of a Linux which runs in parallel to a PyCos native and any other guest runtime environment. And when the PyCos kernel starts up, it uses the system software to statically configure memory and I/O resources at the very early system initialization. Once this is done, these barriers are effective and very strict. That even is true for the kernel itself, which has separate memory areas for the different guest operating systems. Since this happens at startup, the Linux kernel can no longer allocate dynamic memory from the area of the PyCos native or any other guest operating system. If it needs more memory, it will just fail, but not affect the other partitions. We also have time partitioning, which is a fixed flow of time, and the chunks of memory are statically assigned, which means if Linux, for example, is running and using up the time, this has not an effect on the other applications, because even if Linux is running with 100%, after a time partition switch, the other partitions are not affected. We will see later how this works on multi-core and how we have solved the cache issues. So we have tightly integrated multi-core into the time partition mechanism. And in fact, the core affinity is just another dimension of our time partitioning configuration mechanisms. So when you come up with multi-core, there are a lot of problems. In fact, in the avionics world, multi-core was not being allowed to use for a very, very long time. The reason was the worst case execution time. One of the prominent example is the cache. If you have one application that uses the cache in a very extinct way, and you have a time partition switch. Afterwards, the following application, which is running then, needs to rebuild its cache and has serious changes to the worst application, to the worst execution time. And in avionics, this could not be used. In the meantime, things have changed, and we have done everything inside the kernel to resolve these issues. So typically what we do, if the critical partition starts, first we partition the cache as well, and in addition to that, we make a cache flush. When it comes to the behavior in the kernel itself, we have totally removed the big kernel log and replaced it by fine-grained logging. And by this, we can guarantee you that if a system call is being executed in the kernel, there will no other resource partitioning waiting on a global log. There can only be a wait if resources are being shared, and in a safety environment, we won't do that. In other words, we have no interference in the kernel itself. By doing so, Picos was the first operating system that was certified according to SIL 4. So these are what we've done on the kernel. In addition to that, there are also some recommendations we give our customers on how to architect your system that you have no interference on application side. And one of the most simple thing is to run non-critical applications on different cores at the same time, do a cache invalidation, and then only run critical applications in parallel, because those have been certified and it's guaranteed that they do not use the cache in or the I/O memory bus in a non-definable way. When you put all these things together, and the last change we have done is some bandwidth allocation monitoring, which is in the making and will be soon in the product soon. When you put all these together, we can now guarantee that you can even use Picos in an avionics environment. We will now come to the design workflow. Traffic has shown us before how the demo is running inside the SCADE suite. And we will now show you how it runs on the Xilinx UltraScale board. So below we have the hardware here. And then we have Picos running on the R5 code, which in this example runs the SCADE suite model, which has been generated automatically by the tools. On the R53 cores, we have a small POSIX gateway partition, which does the communication with the train simulator. Both Picos instances are talking with each other via intercore communication interfaces. This is some message-based port channeling. In addition to the gateway, we have a Linux partition, and this Linux partition runs a hardware-accelerated Linux, which comes from Xilinx, which has an OpenGL ES layer, and on top of this, we have the SCADE display. Yeah, this is the current setup. We have the UltraScale board, the gateway, the Picos partitioning. To the right, we have the Ethernet connection, which does the TFTP boot. If you see the demo, please understand that we do this all inline, which means once the code has been compiled, it's being transferred via TFTP to the target. Once you have your production code, you will put it in Flash and the system will boot up in a few milliseconds. On the left, we have the so-called Muxa channel, which is a convenience function during development, because typically, if you're running multiple partitions, you want to have a separate console service. So we have built a mechanism into Codio that you can use multiple consoles which are being muxed via Ethernet. And finally, the SCADE module is running on the real-time cores and communicating over intercore with the POSIX gateway. And to the left side, we have a TCP connection to the train simulator, which simulates the real physics in this example. That's the entire picture here, and we will show you now a video which has been prepared by my colleague Shafik.
In this record, we will walk you through the described flow, starting from the software design with SCADE Suite and SCADE Display. We used ANSYS SCADE Suite to design the controller of our autonomous train. The outputs of the controller are the acceleration and brake commands. Meanwhile, the inputs are the speed of the train and the speed target specified by a user. SCADE Suite offers you a language mixing data flow and state machines to enable you to design complex embedded software. In this example, our state machine is calculating the acceleration and braking states using a PI regulation designed with SCADE Suite. SCADE Suite offers you as well the capacity to connect via the ALM gateway to your requirements environments such as DOORS, Polarion, and JAMA. The ALM gateway will import the requirements IDs and descriptions to help you to implement this requirement. In this case, the requirement 4 is specifying that the train should be accelerating if the speed target is higher than the current speed. With a simple click, you can connect this requirement to the SCADE artifact that will be implementing it. Once your design is complete, you can now run the checker to verify that your model respects the syntax and semantic of SCADE Suite. The success of this stage will enable you to generate code and to run the simulation of your model in the SCADE Suite environment. The next step in our demo is to run the simulation of the controller using the SCADE Suite simulator environment. SCADE Suite does not distinguish between the model and the code, and you are running the simulation on top of the code. It's offering you an interactive environment where you can set the inputs to check the outputs values. Let's run the simulation and activate the controller. If we set the target speed to a higher value than the current speed, we will see that the system is passing directly into the acceleration phase. Once you have finalized your simulation and you want to save the scenario to use it later on, if you want to check for your model after some modification, you can save the scenario and load it using these buttons. Another benefit of using SCADE is to access the SCADE reporter. SCADE reporter comes with a qualified reporter that helps you to generate the details of your model and to share with your certification authority. In addition, it has an HTML version and RTF version. I generated the HTML version here, and you can have a look to the details of your models in the report directly. You'll see the list of the constants, the inputs and outputs of your operators, the diagrams that you have created. And in addition, if you have performed any traceability activity with the requirements, you will see the list, the ID of the requirement and its description and the object that is tracing to. Our next stop is to design the DMI of our autonomous train with ANSYS SCADE Display that offers you an environment to design the graphical interface of your system and to interfaces with input via inputs and outputs to the external environment. In this example, the train speed is coming from the train simulator or the train system and is feeding the speedometer of our DMI. SCADE Display offers you the capacity to generate your code via the SCADE Display KCG code generator that is qualified for railways. In addition, SCADE Display is compatible with any system that have an OpenGL driver, such as OpenGL embedded systems or standard OpenGL or the OpenGL safety critical systems. In addition to the standard code generation, you can generate with SCADE Display a code that can integrate with ANSYS SCADE Suite for co-simulation, or you can generate an executable for Windows or an application for Android and iOS to demo your system to your customers. With ANSYS SCADE, connecting the DMI to the control software is a matter of drag and drop of the inputs-output of SCADE Suite to the inputs-output of SCADE Display. Once done, you can run the co-simulation, enabling you to see the exact behavior between the two tools and two environments, such as the speed in this case. Next stop is to perform functional validation and verification using SCADE Test very early in your design cycle. SCADE Test is a unique environment helping you to test your SCADE Suite models and your SCADE Display models. where you can as well link these testing scenarios with your requirement designs via the ALM gateway of the SCADE tools. You can define your scenarios as a sequence of setting the input values of your models and what are the expected values that you want to check. Running SCADE test is running the scenarios on top of the generated code from SCADE Suite and from SCADE Display. It will launch the code generation, and then it will inject the inputs that you have specified in your scenarios on top of the generated code. It will calculate what has passed and what has failed in your tests, and it will generate for you a test conformance report that you can take to your certification authorities, showing the details of the execution of your test and the failure and success of the checks that you have. Once your test scenario has been passed, you can now launch the ANSYS SCADE model coverage tool to validate the percentage of coverage of your models. You can choose the coverage criterion from the list of available choices, such as influence, DC, and MCDC. Once run, the SCADE model coverage will generate for each operator the percentage of coverage and what are the parts of the model that has been covered, partially covered, or not covered at all. It will generate as well a report showing you the details of the coverage analysis that you can present to your qualification authorities. Next stop in our early verification journey is to integrate the generated code from SCADE Suite and SCADE Display into a train simulation environment, such as the train simulation game or any other application that you could have at your disposition. We have updated the SCADE Suite model of the autonomous controller with a set of operators to get the train speed from the train simulator and to set the train acceleration and train brake. Our system simulation environment is now ready, and we can co-simulate the train simulator in the SCADE Suite environment to control the acceleration and the brake of the train. Our functionality is now validated. Let's move on to the integration of the SCADE generated code into the Code.io environment from Cisco. SCADE Suite offers an adapter to generate the code of integration for PikeOS. It will generate the original code of the model, that is the standard generated code via the certified code generation process, plus some integration file for the PikeOS specific environment. These generated files are now integrated into the Code.io environment from PikeOS. On the left, you can see the list of the project, including the SCADE Suite project, where we have our software controller and the integration files into the operating system. On the right, we have the list of the projects and the make targets. In this specific demo, we will install the project into Xilinx board, launching it through the install command. You could have done the same with a QEMU environment if you would like to do an emulation on PC. Let's now move on to the last part of our integration on the hardware in the loop with Xilinx and the train simulator integrated. We are connected to the Xilinx environment through a TFTP connection. Our board now will start up its execution, and it will be ready to run the SCADE generated code compiled with the PikeOS compilers and running on the PikeOS environment. Once ready, we will load the execution of the GMI, and the train simulator is just controlling in the background of our interface. Enjoy your ride with ANSYS and Cisco. I hope you enjoyed this journey with ANSYS and Cisco, and we are looking forward for your questions. And if you have any question, please ask us today, or we can answer your question at any moment later.
Thank you very much, Shavik, and we are looking forward to hearing from you.